Hi, we from Group 4. So let me start with the presentation. So good afternoon, everyone. Today we'll be presenting on spent acid and alkalis, a critical topic in hazardous waste management. Our discussion will explore their impacts on the environmental and health and human health, detection methods, existing or proposed management practices, and some interesting insight. This presentation is part of the coursework for ACT303 solid and hazardous waste, and we hope it gives you a comprehensive understanding of the challenges and solutions associated with these substances. So, introduction. Spent acids and alkalis are common hazardous waste produced during industrial and laboratory processes. These substances, such as sulfuric acid or sodium hydroxide, are corrosive and reactive, posing significant risk of significant risk if mismanaged. Improper disposal can result in soil degradation, water pollution, and severe health risks to humans. Through this presentation, we aim to provide an overview of their environmental and human impacts, discuss detection methods, evaluate existing management practices, and propose innovative solutions. By addressing these aspects, we hope to highlight the importance of sustainable waste management practices for mitigation risks and protecting ecosystem. So, for the definition and description, spent acids such as sulfuric and nitric acid are corrosive substances rendered unusable due to contamination or overuse. Similarly, spent alkalis like sodium hydroxide solution are often diluted or taint, tainted with impurities. These wasted originate from industrial cleaning processes, chemical reaction, and even agricultural activities. These properties, high reactive reactivity and corrosiveness, make them particularly dangerous, capable of causing burns and damage ecosystem. Understand the source of the characteristic of spent acids and alkalis is essential for devising effective management and treatment strategies. Let's now explore how these substances impact our environmental and health impact.
The environmental consequences of spent acids and alkalis are severe. Spent acids lower soil pH, destroying the microorganisms that are vital for nutrient cycling, rendering the soil infertile. On the other hand, alkaline waste increases the pH of water bodies, disrupting aquatic ecosystem and leading to fish to die off. A notable case is the Siang River incident in China, where improper disposal of acidic waste caused large-scale ecological devastation. Such examples highlight the urgency of managing the substance to prevent biodiversity and prevent long-term damage to natural systems. Spent acids and alkalis pose significant health risks to humans. Direct contact can result in chemical burns, while inhalation of acid vapors or alkaline mist irritates the respiratory system and can lead to chronic disease like bronchitis. One infamous incident that illustrates the danger of mishandling industrial waste is the Bhopal disaster. Although it primarily involved toxic gases, it highlights the catastrophic consequences of poor hazardous waste management. Proper handling of spent acids and alkalis is crucial to safeguarding public health and preventing similar disaster in the future. Detecting spent acids and alkalis involves several techniques. Field methods like pH testing provide quick insights into acidity and alkalinity levels. Laboratory techniques such as titration that determine precise chemical concentration. Advanced technologies like spectroscopy help to identify contaminants in waste streams, including heavy metals. For example, inductively coupled plasma spectrography is widely used to analyze hazardous components in spent solutions. Regular monitoring using these methods enables early intervention, reducing the risk of environmental contamination and human exposure.
Industries currently employ several strategies to manage spent acids and alkalis. Neutralization is the most common practice, where acids and bases are treated to form harmless byproducts like water and salts. Recycling is another effective method, allowing spent chemicals to be purified and reused in industrial processes, reducing both waste and costs. Governments enforce strict regulations, such as Singapore's Environmental Protection and Management Act (EPMA), which sets discharge standards to limit pollution. Despite these measures, gaps in enforcement and technology adaptation remain, requiring further improvements. To further reduce waste production, industries can adopt innovative solutions such as closed-loop recycling systems, which allow spent acids and alkalis to be reused continuously within industrial processes, minimizing disposal needs. Advanced neutralization techniques such as using nanomaterials can enhance treatment efficiency while lowering environmental impacts. Governments should incentivize these practices through subsidized and tax benefits for adopting eco-friendly technologies. Such measures not only reduce hazardous waste but also improve economic sustainability by cutting waste management costs.
A fascinating aspect of hazardous waste management is the variation in international standards. For instance, Singapore EPMA requires wastewater pH to remain between 6 and 9, while the US RCRA focuses more on the toxicity of waste. Another point to consider is the carbon footprint of recycling. Recycling spent sulfuric acid, for example, reduces CO2 emissions by 50% compared to producing fresh acid. Such insight underscore the importance of sustainable practices which not only protect the environment but also align with global carbon reduction goals. Proper management of spent acid and alkaline is essential to minimize their environmental and human health impact. Industries must adopt recycling systems and explore advanced technology like nanotechnology for waste treatment. Government should enforce stricter regulation, provide financial incentive, and promote collaboration between industries and researchers by combining techno- technological innovation, policy enforcement, and global cooperation. We can achieve more sustainable and effective management of hazardous waste, ensuring a safer future for both people and planet.
Okay, thank you. That's all for our group 4.